Okay, guys, this is a little video I want to make on y'all's review for the test 8 on similarity. Okay, so number one, we're just gonna go through this rapid fire. So you see that picture right there? You basically see that that's like a small one into a much larger one. It's like a mini and then a bigger one. Basically, those are similar. So you want to get similarity statements right here. Remember this right there? That means similar. That means congruent. You know, where you have that squiggle on top of equal sign, that means congruent. So what's going to be congruent to angle H, and that's going to be angle B right there. So that's going to be angle B because you can see they're going to be the same angle. Okay, and then over here you're saying GH. Well, where's GH? GH is this one right here, divided by DJ, which is right here. So what is that going to be equal to? Well, if you have AB over here, the one that's equivalent to that is going to be DC. Okay. Number two, are the polygons similar? If they are, write a similarity statement and give the scale factor. So first of all, we're looking at these two right here. So we have this side here at the bottom, and then we have that side over there. So here we have the side over here. We have both of them right here, and we're basically just trying to find out, are they similar? So if they are, we need to examine their scale factors. So I'm going to say, I usually try to do second over the first, but you could have always done second over the first over the second as well. So I'm going to say 10 over 12 is 5 over 6. Divided by 15 over 18, which is also going to reduce to 5 over 6. So the answer is yes, those are the exact same. If you had done the opposite here and you said 12 over 10, and you had done 12 over 15, 18 over 15, they would have been the same thing, but they would have been flipped. You would have had 6/5 over 6/5. Okay, either way, they would have still been the same. Okay, number three, the polygons are similar. So they're telling you that they're similar, but they are not necessarily drawn to scale. Find x. So x is right here. Okay. Now when I first did this, I solved for y first, but they didn't want that. They're just looking for x. So we're going to have to make a couple of proportions here. So I'm going to say x minus 1 over 6. Which is going to be right there, and this is going to be equal to what else is given. They're also giving you could have said 32 over 24, or you could have done 16 over 12. I just went with the 32 over 24, but you could have always done 16 over 12 as well. You'll get the same thing. Okay, and then from here we just got to solve this, so let's cross multiply. 24 times x minus 1. So when we do that, we're going to have 24 times x minus 1 equals 6 times 32 is 192. And then once we get to this, we're going to divide by 24, which I can do because I haven't distributed that yet. Divide both sides by 24. The cancels right there on the left. You have x minus 1 equals 192 over 24 is 8. And then I don't have the room for this, but if you add 1 to both sides, plus 1, that cancels there on the left. You just have x. 8 plus 1 is 9. Okay, so next page. So number 4. We have if the diagram of a landscape plan, the scale is 1 centimeter for 10 feet. Is the diagram the trees are 3.1 centimeters apart? How far are they apart? Are the actual trees? So you could have said 1 over 10. The first time I did this, I did 1 over 10, but I'm going to go 10 over 1. So 10 over 1, since we're looking for the number of feet. So setting up your proportion, 10 over 1 equals I don't know what over 3.1. Then just cross multiply. 1 times x is just going to be x, of course. 10 times 3.1 is just going to be 31. And of course, this is going to be in feet. Okay. Number 5. Are the two triangles similar? How do you know? Well, first of all, you're given two angles here. Okay. And we can find out the third one because remember the three angles of a triangle have to add up to 180 degrees. So I'm just going to say 180 minus, here I added these together, 60 and 54 make 113. 180 minus 113 is 67. For the other one, I have 60 and 67, so I'm doing the same thing. 180 minus, and then 60 minus 67, or 60 plus 67 is 137, or 127, sorry. 180 minus 127 is 53. So they all have the same angle measurement, so they have to be similar. Okay. And of course, you could have always said, because they have the same angles, two of the same angles, that's the AA postulate. Okay. Number 6, state whether the triangles are similar. If so, write a similarity statement and the postulate or theorem you need. So, first of all, we're given 21 here and 33. Okay, so this is like a mini inside of a larger one. Okay, so when we're doing our proportions here, first of all, I need the entire thing up here. So 33 and 11 is 44. The same thing down here, I have 21 and 7, which make 28. So the ratio that you need is, the ratio you're going to have 44 over 28 equaling, equals 11 over 7. Okay. Yeah. So that's the way that's going to be. 33, you could have had 33 over 21, which is 11 over 7. It's going to be the same thing. So 144 over 28, you can see, is also 11 over 7. You have the same ratios, so they have to be similar. Okay, and number 7, here we also have like a smaller one inside of a larger one. It's like a mini inside of a larger one. Which theorem or postulate proves that the two triangles are similar? Here you're given that this is 10 and this is 20. You could have always done, okay, this is 15 and this would have to be, you could solve for this down here, but they didn't ask for that. Okay, this is just going to be AA similarity, because remember, this is the mini inside of a larger one. They look exactly the same. So if whatever angles this one has to have the exact same thing, just larger sides but the exact same angles. Okay, number 8. Okay, Michelle walked, or she wanted to measure the height of her school's flagpole. She placed a mirror on the ground 48 feet from the flagpole and then walked backwards until she was able to see the top of the pole in the mirror. Her eyes were 5 feet from the ground and she was 12 feet from the mirror. Using similar triangles, find the height of the flagpole to a tenth of a foot. Okay, so when we're doing this here, first of all, I don't know what this is, so I'm going to call it X, and I know that this is 48. Likewise, you have this over here. She's 5 feet tall, and she's 12 feet away. So doing your proportion right here, I'm going to say X over 5, okay, because the height's X over 5, and then 48 over 12. And then you can cross multiply. You could have always, well, I'll tell you that part in a second. So if you cross multiply, X times 12 is 12X, 5 times 48 is 240, divided by 12. I don't have the room there. So divide by 12, that's just X. 240 divided by 12 is just going to be 20. Anyway, what I was going to say is 48 divided by 12 is 40. So you could have just set 4 and then multiplied both sides by 5. You would have gotten X equals 20 also. But, you know, to be consistent, since we're doing all these with ratios, that's why I did it like that. Number 9. From the similar triangles in the diagram, write a proportion using the ratio WX. Well, WX is this one right here. That's short leg, over WV. Well, WV is this hypotenuse. So that's the way you got to think of this. Short leg over hypotenuse, because it's the longer leg over here. Okay, so if you do that for the larger one, okay, well, where is my short leg for this big one now? Well, the short leg for the big one now is going to be VX, which is going to be right here. Okay. It's going to be Vx over, and then where's your hypotenuse? Now my hypotenuse is Vy, okay? And that's all they wanted. They just wanted you to get that ratio right there. Okay, number 10. What are the values of A and B? Okay, so remember yesterday when we were talking about the geometric mean, you got to set up your ratio. So remember, part of the hypotenuse, part of the hypotenuse divided by that altitude. Remember, this would be your geometric mean, so that's why it's 8 over 6 equals the 6 over the remaining part, in this case A. So now we're going to solve for this. I'm going to do this before we solve for the B, so because we're going to need the A for the B. So cross multiply, A times A is 8A, 6 times 6 is 36, and then if you divide that, both of these have a 4 in common. 4 goes into 36 9 times, 4 goes into 8 2 times, so this is 9 over 2. Okay, if you had 4.5, that would have been fine, but remember, fractions are your friend. For B, remember when we had this here, Again, one of those from that video that we had seen for geometric mean. So if you're talking about the legs, you can also get this, but it's a different formula. You're saying B equals the one right in front of it, that part right in front, in this case A, times the entire thing right there, which is going to be 8 plus A. Okay, and then from there we can just distribute the A. 8 times A is A squared. 8 times 8 is 8A. And now I know what A is. It's 9 over 2. 9 over 2 squared is 81 over 4. 9, and then 81 over 2 over 9 over 2 here. So I'm going to have 81 over 4. When I distribute, I'm going to have 72 over 2. And then here, I just went about trying to get common denominators. 2 goes into 4 2 times, so multiply top and bottom by 2. 144 over 4. That's going to be 225 over 4. And if you do 225 over 4, then you get the square root of both sides. Square root of b squared is b. Square root of 225 is 15. 15 times 15 is 225. And then, of course, square root of 4 is 2. If from right here you just got the decimal, that's okay. It's just that when you get to this part and you have to get the square root, you would have b squared equals that decimal. When you get the square root of that, you would have gotten 7.5. Either way is the same thing, but remember, fractions are your friend. Okay, number 11. Find the length of the altitude. Okay, so in this case, there's your x, your height right there. To the hypotenuse, the triangle is not drawn to scale. Okay, so I'm going to say, remember from the geometric mean, so I'm saying 5 over x equals x over 16. Okay, this is straight from the video we saw yesterday. Do cross multiplying right there. X times x is x squared. 5 times 16 is 80. Square root of both sides. Square root of x squared is just x. Square root of 80, that's like saying the square root of 16 times 5 is 80. And I picked that because square root of 16 is 4. So I'm going to say square root of 16 is 4, and then times square root of 5. Bam. Okay, now number 12. So let's go to the next page. So number 12, this is a whole lot of stuff right here, like wording. So Kristen lives directly east of the park. The football field is directly south of the park. The library sits on the line formed between Kristen's home and the football field at the exact point where the altitude to the right triangle is formed by her home. The park and the football field can be drawn. The library is 2 miles from her home. The football field is 8 miles from the library. Blah, 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 blah. They drew you a picture, okay? So you got 8, you got 2. You need to get this x right here, and then you're going to need this side over here. So just like the one we just did. So first of all, geometric mean, so set up your ratio. You're saying 2 over x. I call this x. So 2 over x equals, and then x over 8. Of course, at this point, I hadn't solved for the x yet. Anyway, when you solve for that, cross multiply. X times x is x squared. 2 times 8 is 16. Square root of both sides. Square root of x squared is just x. Square root of 16 is 4. So now you know that x is 4. So now remember that other one that you're going to do for b, or not b. In this case, I called it y. So y squared is going to be this side over here times the entire thing there. So I'm going to say, oh, actually, you could have done that, but actually what I did is, since you know that this part, and then you're just looking for this y here, and you have this, I just did Pythagorean theorem, which is actually simpler. It was cool if you did it the other way, saying y squared equals 8 times 10, which should have been 80. Either way, it's still going to be the same thing. But I just did Pythagorean theorem. 4 squared, since you know x is 4, 4 squared is 16, 8 squared is 64, 16 and 64 is going to be 80. So y squared is going to be 80, square root of both sides, square root of 80, just like the one we just did. That's going to be square root of 16 times 5. Square root of 16 is just 4, and then times 5. Okay, number 13. What is the value of x given that PQ and BC are perpendicular to each other? So you know that this is 8 and this is 12. This is 18. I just don't know what x is. So what you can do is you can get this ratio right here. So 8 over 12. And this is going to be equal to this entire side, x plus the 8, over this entire side here. 12 plus 8 is 30. And now we can just cross multiply. 12 times x plus 8 equals 8 times 30 is 240. Divide both sides by 12. That cancels. They're on the left. You just have x plus 8. 12 goes into 12 goes into 240 20 times. You could have just said 12 into 24 2 times and then the 0. Anyway, subtract 8 on both sides. It's going to get x equals 8. So x is 8. X equals 12. Number 14, plots of land between the two roads are laid out according to the boundaries shown. The boundaries between the two roads are parallel. What is the length of plot 3 along this road? Okay, so you're just going to make a proportion there. Okay, so x over 64 is going to equal 40 over 48. Okay, if you had wanted to say x over 40 equals 64 over 48, you would have gotten the same thing. Okay, and cross multiply. X times 48 is 48x. 64 times 40 is going to be 2560. Divide both sides by 48. 2560 divided by 48 is just going to be 640. Dividing that, I'm just reducing this now. These both have a 4 in common. 4 goes into 2560 640 times. 12 goes into 48. 4 goes into 48 12 times. Both of these have a 4 in common. 4 goes into 640 16 times. 4 goes into 12 3 times. I wrote it like this to get 16 thirds because your answer is in the back is 5 1/3, which is what 16 over 3 is. Okay, and then the last one, 15. You have this. What is the value of x? So we have this just like the one of those that we had just done. You have x, and then you have this side right here, x minus 2. And then this is like a smaller triangle inside a bigger one. So the ratios are going to be the same. So you could say x over x minus 2. And then equals, we need this entire one right here. So x plus 5, those two x's make 2x, and then plus 5. Same thing here, x and x is 2x. Negative 2 plus 1 is minus 1. So setting up that ratio, now I'll just cross multiply x times 2x minus 1. And then x minus 2 times 2x plus 5. Now when we do this, we're going to arrive at this because we just multiply those together, and then x times 2x minus 1. Here you're going to have to FOIL, which you should remember from Algebra 1. Remember, when you FOIL, you're just saying the first times both of those, and then the second part times both of those. X times 2x is 2x squared. X times 5 is plus 5x. Negative 2 times 2x is minus 4x. Negative 2 times 5 is minus 10. And then over here, just distribute the x. X times 2x is 2x squared. X times minus 1 is minus x. Okay, now when you try to move this from one side to the other and you subtract 2x squared, they're both going to cancel each other. So what I'm going to be left with here, 5x minus 4x is just x minus 10 equals negative x. We need the x's on the same side, so I'm going to add x to both sides. When you add it here, that cancels there. X plus x is 2x. Add 10 to both sides, that cancels there on the left, which is just going to be 2x equals 10. We just want x divided by 2. We're going to get x equals 5. Okay, guys, that is your entire review. If you have any questions, please rewatch the video. I will see y'all in class. Bye.